Welcome to Cassandra.Lunch number 127. We'll be discussing a topic with our great friend and colleague, Cassandra.Link. We'll spend a few moments here waiting for some people to join, and then we'll discuss some housekeeping items and then move right into the discussion. All right. Again, welcome to Cassandra.Lunch number 127. Don't forget to like and subscribe, as well as turn on the notification bell if you haven't already, so that you can get notified every time we post a video or go live. Today, we will be covering modeling an effective Cassandra data model with storage attached index with our speaker, Cassandra.Link, and we're going to move forward with that. I'm really excited for this talk. The co-organizers for this event are Rahul and Akwi. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the Cassandra community around the world, drop an email to Akwi. His email is listed below. If you yourself are interested in giving a Cassandra lunch or speaking at our sister event, Data Engineers Lunch, feel free to reach out to Akwi for that as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data, and you can find out more about all the various groups and events at datacommunitydc.org. At Data Engineers Lunch, we cover everything from the ingress and egress of data to everything in between. We cover databases, data wrangling, ETL, reverse ETL, and all the tools and processes in the data engineering world. If there's anyone new that would like to say hi, what brought you here, or what you hope to get out of this, drop something in the YouTube chat. If you are watching on YouTube, don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. I know we have some special plans next week for the ScyllaDB Summit. So push that notification bell so you can hear about the special events next week. Some rules for this event. If you have a question, please ask it by posting it in the chat. We will get these messages to Vel so that he can answer them in real time. Always be polite and courteous to others, and this is a community, so please share what you know. Here at Anant, we design, build, and manage global real-time data platforms. And surrounding Cassandra, Spark, and Kafka, Cassandra is our bread and butter. Thanks to the sponsors for this event, Anant and DataStax, and of course, our other sponsors. Thanks to our organizational sponsors, including George Washington University, who helps provide venue space when we have in-person events. Thanks to all of our institutional and organizational sponsors. If anyone has any job offers or you're looking for a job, please drop links and we will get them transferred we'll make sure that they are broadcasted. If you have any meetups, hackathons, classes, or conferences that you would like to promote, feel free to drop those links in the YouTube chat as well. We currently host Cassandra.Lunch every Thursday at 12 p.m. EST, that's now. We're also looking for a variable time slot to cater to the worldwide audience. Our sister lunch, Data Engineers Lunch, takes place every Monday at noon Eastern. And all of our videos are available on YouTube, starting at Cassandra.Lunch number 10 on our Cassandra.Lunch playlist. Also like to highlight our resource Cassandra.Link, which is a hand-curated site with resources for Cassandra and the Cassandra ecosystem curated by the team here at Anant. Finally, we have released our 13th runbook, emphasizing token imbalance, updating your Java heap size, and using node sync. With that, I'm going to pass our presentation to Vel. Vel, go ahead and start sharing your screen. We're ready to go.
Okay, thank you, Nick. Thank you for the introduction. Okay, hello everyone. Okay, good morning, good afternoon, good evening. Okay, as Nick's point is, my name is Senthil Vel Palaniappan. People call me as Vel, VL Vel. Okay, so I am the platform architect, and I have been using the Cassandra for more than 6 to 7 years. Okay, and apart from that, then I do with a lot of the RDBMS steps and most of the things with the Java's, Spark, and Cassandra. Okay, those are the things. And apart from that, then I'm doing a lot of platform architecting in the cloud base. Okay, uh, let me share the screen. Okay, so okay, I think everybody can see this. Okay. This is a topic mainly talk about the how we can effectively model a Cassandra data model with the storage attached index, because this storage attached index is from available in the AstraDB and from the DEC 6.8. Okay, so people who want to use the AstraDB and want to do some project, and this will be very effective one. So of course, if you have a DSC 6.8, then there also that you can do with the storage attached index, then you can effectively how you can manage with the data model. Okay. So now if you look at the secondary indexes with the data stacks.
Bell? Sorry,
Yep.
we can't see your screen.
Oh my God. Okay. Okay, is it visible now?
Yes, we can. Thank you.
Yeah, okay, sorry, I think, okay. So as I mentioned, actually, sorry for that, actually. Yeah, Cassandra secondary indexes, okay, there are the three things, okay. Normal secondary index, okay, that's what it was started, but it was not so effective, okay, because when you do with the secondary indexes, that index is being created only to that particular node, because you know that Cassandra is a distributed scalable architecture with it will have a peer-to-peer networking and make the communication. Okay, so all this data is sitting in particular node based on the your partition key and everything. So with that secondary indexes, then it try to put it in each one of those nodes. Then it is very difficult because every time that you have to run it, and each time then there are so many things. Okay. Now, for that, actually, after for a couple of releases, and maybe more than 5 to 6 releases, it has come with storage attached secondary indexes. It is something like that based on tokenized live inverted index, like the Lucene and other things that we do. Same thing that they come up with their storage attached secondary indexes. But there also, it is going to be a lot of disk spaces that is being used, and it is being used as a separate files and everything. So there are also some lot of drawbacks and everything. So with all these secondary indexes, secondary storage indexes, they come up with something called storage attached index. So it is called SAI. So throughout that slides that you could see SAI, okay, that is storage attached index. So with that storage attached index, what did you get benefit out of it? Okay, I think most of you actually, when you model a table in Cassandra, actually you go by normally with the query specific table, that is query by design model. Okay, so each query, how you can define your tables, or how can you design your tables? Okay, so let us say that I have a user with the login by email. There is one table user, there is a one. Then some of this column that you take it and put it there because say something they say that okay, you can denormalize your tables and something. What are the columns that you want to duplicate it? Okay, this is how that it is going to be happen so far. But these things and all very much reduce once you go with the storage attached index. And more or less, it is going to be a model that how we do it in the RDBMS, same stuff, but still it is behind the scene, it is only going to be a multi-node, no SQL with the Cassandra only. Another thing is it occupies very less disk space. It doesn't take much disk space. It occupies very less disk space. Okay. So with that, actually, these are the benefit of storage attached index. So what is exactly storage attached index? Okay. It is highly scalable. Okay. So if you add the nodes or something like that, then it is being copied. Even if you remove the nodes, then it is being taken care with the other nodes and everything. And even it's globally distributed. Globally distributed means actually you can have a cluster not only from one data center, that is from the other data centers that you can use it. And another thing is it is wherever it is data with that attached index is there, that it is very much associated to the SS table attached. Okay, the SS table attached something like that. Okay, each table and the data, then it will create SS table. Okay, so I think most of the things what are there in the Cassandra, okay, how it is being pushed from mem table to SS table. Okay, so each one of those indexes also very much attached to the SS table while during the write itself. Those things that we will see in the next couple of slides. Yeah. Okay. Fourth thing is it highlights on disk index. Okay, and it is there is something called DSC thread per core infrastructure. Okay, I think you can find it in the data stacks things. What is thread per core infrastructure? Okay, and another thing, as I mentioned earlier, it is available in DSC 6.8 and AstraDB. Okay, in these two network and the subsequent one, then it will have those things. Yeah, and mostly it is very much deeply integrated into the Apache Cassandra storage engine. That is, it is integrated to that. So with that, actually, we could be able to read the data, write the data very efficiently, and it will create some more benefit of reading the data. Okay. So with that, the same engine, so integrated to the storage engine, so it will be very useful for us to design very good model. And that's all from the what it is and how it is being used. Now, what are these index features? Okay, so what are the different data types that storage attached index can be used? Okay, so these are the things you can use an ASCII, begin, date, decimal, double float, int, inet, small int, text, time, everything that whatever it is there that you can use it. And you can use it in the collection types too. But only thing is, if you have an UDF, user-defined user-defined UDT, user-defined types, actually that you cannot use it. I think Cassandra doesn't support the user-defined types with this indexes so far. Maybe we can check it in the later releases, but so far it is with only with the collections and with the some of the basic data types. So with this basic data, what are the query operators that we can use it? Okay, for numeric, we can use it with equal, less than, greater than, less than or equal to, greater than or equal to. With the collections, we can say with the contents. Collection is nothing but one of the data types, the Cassandra with set, list, and map. Okay, so contains mostly with the contains is for the set and the list, and contains with the key is for the map. This because you know that map is the key value pair. So contains the key, so we can get to pass the key. Okay, in the where condition with this mapping. So we will get those value with this key. So what are the results available for that particular row that we can get it, and with the value also, with the map value also, then we can get the the whole rows out of it. Okay, that is a good advantages of having with the collection and the storage attached index. For string, it is only the equal, so it has to be exactly equal. Suppose I put name as well, okay, so uppercase or lowercase, so however that I inserted those values, it has to be the same one. Okay, so there is no prefix, suffix, or something like percentage. It's not there so far with the storage attached index. Only the equal sign only there actually. Yeah. So fields for indexing. So you can index the primary key and as well as non-primary key. So non-primary key that is being used very much. Only one thing is on the partition key, first column on the partition key, we cannot do the storage address because that's going to be your partition key. Then from that, then all your token and everything is going to be there. So with that, you cannot do anything. But rest of the things, suppose you have a partition key 1, 2, 3, you can have it the storage for 2, 1, 3, not 1, and any other non-primary key that you can have a you can have a storage attached index to that. Yeah. And one more thing, you cannot combine 2 or 3 fields, okay, columns, 3 columns that you cannot do that. Okay, only one for each one of those things that you should do that. And even there are certain limitations that we can have it for the indexing for each one of those tables. Even if you look at the shared AstaDB, then it has something like that. Actually, you cannot have more than 50 or something like that indexes. Okay, SA indexes for one databases. Okay, something like that is there. So if you want in DSC 6.8 or something, suppose you are using it, okay, you can. There are certain parameters in the Cassandra.YAML. So with that you can increase it. Okay, whether I can able to backup and restore with the storage attached index? Yes, of course, it is available. It is called zero copy streaming. That's as I mentioned that actually even you add a new node or you remove the new node. Okay, so you don't have to do the serialize and do something on it because anything it is very easily that you can copy and put it there. And how can I check it? Okay, whether that storage index is there with the observability because it's available in the DSC Off Center, okay, and Grafana and your virtual tables that you can find those information. Okay, so there is no chat. Okay. So the next, so these are the features available for the storage attached indexes. Okay, let's go to the next screen. Sorry. Okay, now I have an index. Okay, so I created in one of those columns as an index, second is storage data index. Okay, so how this data is being pushed into the engine and how it is being stored. Okay, that's what this talks about, the right path. So a claim send a mutation. Mute is nothing but your insert or update or what are the delete also. Okay, let us assume that. Okay, so when you do that, so there is something called mem table index. So the thing is, Cassandra has something called mem table. Okay, whenever you do insert or update, then this information is pushed into the mem table. Okay, first it'll go to commit log at the same time, then it'll go to the mem table index. Okay, so during the when you push into the mem table index, suppose it has a storage attached index, okay, on that particular column, so there it will get indexed in mem table. So once mem table is full, then it will be pushed to the file as an sorted string tables that is called SS table. Okay, yes, they are written. So how they are written? The same thing, how they are indexed, the same thing, it will push into the SS table and kept it there. Okay, so by mem table itself that I have a indexing. So with that, then it is propagated to the sorted string table with SS tables. So very easy from starting to end, it is very easy for that. Okay, and each mem table, I think you know that as with Cassandra, you know that it is a specific to particular database table with the structure and everything. And SA is notified of all mutation against the current mem table. So with the mem table, we will know that, okay, any mutation is happening. So SA will get notified. So apart from that, actually SA supports partition deletions, range tombstones, and row removals, because one of the thing writing and updating and deleting, okay, we will have a lot of tombstones and all those things. Okay, so SA also support with this, with the partition of the deletion and range tombstones and row removal, because when you remove something from SA table and mark as delete with the tombstone, at the same time, then we have to make it in the SA saying that, okay, for these things, there is a tombstone on a row level or field level, all those things, that it will take care of it and we'll keep it there. So it will also, of course, as I mentioned, it is a insert and update is being handled over there. So this is the starting point for the storage that is in the right path. Now, next thing, so this more information that you can find it in the data stacks. You can say that SA right path, then so much of information will be there. We don't have a time for this, but we are going to the demo. So we will be, I minimize those bullet points. If you want more detail, that you can go and check it in the data stacks, SA right path, that documentation. So you can have more information onto that. Yeah. So you had a right path, then how this right into the flush that it will take it, how do the thing it will do. So mutation occurs, it goes to mem table. Now third part, SA know that, okay, there is a mem table mutation happen. There it creates an in-memory representation of the index with primary key. Okay, so all these things are taken care. So it knows that what is its primary key, and when we create an index into that, how to get those primary key, because based on the primary key only, then it is has to go and read it from there. All those information, then it will have it in the point number 4. SA creates the in-memory presentation. Then after that, it will push into the disk. When it's doing the indexing, it will do the 3-part. Okay, thus 3-part is for each row, a row ID is generated, and each disk mapping of row ID to their corresponding token values. Okay, so for each row ID, what is this corresponding token value, that is also created into that. So there is an SS table partition offsets. Okay, it will say that for this value in SS table, in which offset location it is available. So those information will be there, and temporary mapping primary keys to the row ID. So with the primary key to the row ID, it will be there. So we know that, okay, which row to read it using that primary key. So all the things that is required for to read the data using the non-primary key, okay, non-primary, non-partition, non-clustering key with this non-primary key value. So these are the behind the scenes is being happen. Okay, then it gets stored into the SS tables and it is attached indexes. So this is how it gets stored into SS table onto the file. Now next we'll go to the read. So read, it is something like that. So you will get the read. So it will have something like, it will do the query planning actually. That's a very interesting part of it actually. It will do the query planning for the available column index in a single query. Okay, so I mentioned that actually that previous releases and the normal second index that you have to use, when I use the var class, I have to use only one index. Okay, I cannot have a multiple indexes, but with SA indexes, I can have more than one indexes. Okay, where name equal to something, where age equal to something like that. Okay, those things. So it will go there and read from all this SS table with this value, and it will have a merge. With that, it will take a top keys, and with the post filtering, then it will go there and with the based on the key, based on the primary key, it goes there and take the data and do all the filter and everything and return the rows. Okay, this is how it is happening in the read path. Okay, so This information also available in the Cassandra docs. It has some more information that you can have a look onto that. Okay, so this is how to do that. So what is the next? Next one is the demo. Okay, here I am going to.
Now, before you move on, we had a question come in. Is the only available DSE Cassandra? If so, DSE has inbuilt Solar nodes. So what's the difference between using SAI versus Solar queries?
Okay, Solar query still have been used it, but only thing is Solar query going to be indexed in the different file system. Okay, it is going to be a heavy enterprise thing, but here it is a very lightweight here.
Thank you. That was it. That was the last question. Thank you.
Okay. So let me see demo. So I have a customer have an order. So he placed an order. Okay. Now customer ID, customer name I have, order ID, customer ID, order date I have for this order, and there is a shipment. Okay. This for this customer, there is a shipment. Okay, for this order, share the shipment ID, order ID, shipment date. Okay. With these things, okay, let's go. Okay, how we can do with this? Maybe we can go with the customer and order with one-to-many relationship, how it can be. Okay, even with one table and with the other table, two tables, that how we can do with that. Okay, so this is the high level or entity thing that I'm going to explain it. Next. Now, before going dive deep into that, actually, so what is the value addition, value of storage at the index? So we can reduce the tables because previously we used to do a lot of query. Okay, query by design for each query, then you write in different tables. Okay. And another thing is you can add a non-primary keys for index and queries that you can do is. And one more thing, we might have used a lot of materials view. Material view is nothing but one more like a table, but thing is you will have a different keys and everything, but you will find the storage and everything very, very huge because you will have a same copy of the stuff that is being used in the new materials, whatever that you are created it. So with that, actually, it is going to be very large. Suppose I have a 2 gig of data. Okay, then it will become, suppose I have created 3 or 4 materials view, then it will become 8. Okay, something like that it will go. So with this storage at index, it will not have any issue onto that. Okay, suppose I don't have any SA index. Okay, now if you look at this, I have a customer, SA index, fine. Now, I want to find customer who has an orders. Okay, then in that case, then I have to go for a separate table because I need to create something called customer order table. With SAI, I don't require it because I can directly take it, the customer name, okay, or order reports. And same thing with the order shipment and shipment. Like that, there are so many things. Even for this order, someone say that, okay, I want the order this date to this date that I want to get it, the orders, what are things orders, and what are the customer. There are so many. So if you go the real use cases or real query, that is so many things. So we had to go and break so many things, break something like break our heads to create so many tables and everything. So with this new thing that we can able to eliminate most of the duplicate tables and reduce it, and it look very good. And wherever it require, then we can add those things, can increase it, but we don't have to create a lot of tables like that. Okay, so let's go to the demo. Let me connect it to okay. So I'm using okay, I think I have opened so much of time. So this is my key space SAI demo. Okay, so here I have I already created a table. Okay, So if you look here, actually, the table is customer. Okay, I create ID, name, city, created date, state, zip code, text. So this is my partition key. This is my clustering key. Okay, these are the two things that I kept it there. Okay, and what I did is I created one more custom index called customer name IDs customer using storage attacks index. That's all I have done it. Okay, so I don't have there is no data. So what I do is let me
Hey, Val, we can't see your
okay, new share. Okay, every time. Sorry. Where is it?
Thank you. We can see it now.
Okay. So, okay, this is the table I mentioned. It's a customer. Okay. ID, name, city, when it was created, and which state it is this customer belongs to, what is the zip code. So when I say primary key, this ID is going to be my partition key, and the name is going to be a clustering key. And I already created one index under the name of customer name. Okay, I created one index, but I didn't add any data into that. Okay, and let me close this. Oops. Oh, okay, I think it was.
Hi, Val. Could you talk our viewers through what you're doing and what you're trying now?
Okay, I'm just going to add some more. I'm going to add some data into that. Okay. Is it visible that what I'm doing it?
It is. Thank you.
Okay. So I create a table for customer. Okay. That and I created one more custom index storage that has index with the customer name IDX. Okay. So I'll add some more data into that. Then after that I want to show more about how we can use this storage as index. Is that okay?
Yes, thank you.
Yeah. So state. So name, city. Okay. I think this is wrong. Okay, do you know what is the zip code? DC, any zip code?
20002.
Okay. So let me put something in the Western region. So what are the city available? Seattle, then I will say some number, okay. Now let me check it out. Okay, select star from customer. Okay, these are things available. Okay, so select star from customer, their name equal to Nick. So I can able to see those things. Okay, now same thing. Let me try it out. Find from the state. Okay, so where state equal to WA. So I getting a message saying that you cannot execute this query. So it requires a filtering and all, then you use allow filtering. Okay. Now I say allow filtering. I get the data, but the only thing is it is a very dangerous query using allow filtering because it will go to all the nodes in the cluster, then try to get it. Suppose you have a huge of data, then it is a problem. Okay, so what I'm going to do is here actually, so this is what that I need to find out because I want to find it out the customer who is there in the particular state. Okay, just for my analysis purpose. Okay, so what I do is, okay, so I create a custom index customer_state. This is the index name that you have to provide it on customer. Okay, this is on the state using done. Okay, so now you could see this. Okay, as I mentioned, I think you can use only one column as for the custom index. Okay, this storage at an index you can use only for one column in a particular table. Okay, here I have created a customer state IDX is the name of the index on the state. Okay, now let us, without using allow filtering, now I am going to call this state WA. No error, nothing. So it was able to bring it up very quickly. Now, if I go and look for describe table customer, now you will see there are two indexes being used. Okay, as I have not add anything with the name ID or something VA, WA or something for the state, nothing was there. But only thing is I have used this. So let us see, can I add some more rows into that? Okay. 0, 1, 2, 5. So I added in the Washington area. So one more people into that. So let's see. So select star from customer. So I could see two VWA are there. So I'm going to select. So I could be able to see get those records. Okay, so easy. Previously, what would have done is we could have created a table called customer with the state. Then you will have a state as a partition key or what is the primary key. Then you will have a name into that. So with ID and everything. So you will get all those things. Then with this ID, you go and bring up the, because it is always a 2 pass, 3 pass, something like that, or might have been used a lot of information, duplicate information. Okay, with that there are so many tables. Now without that, how we created in the RDBMS the same thing that we have been used here. So with that, actually we are able to get the data as quick as possible. And what are the thing that with the query by design that we are not going deviate, still use the query by design. But the thing is how we model it and how we can efficiently use the data model using the storage attacks index. So with that, actually, we can able to correlate with all the tables and everything, even with the orders. Okay, you an order ID, customer ID. So with that order with the customer ID that you can create, because UID that you can create it. Okay, so with that you can create those information. Okay, let me create one table order. Let's say orders. Okay. This is my UID. Okay. Then I say customer ID. This is also my UID. Okay. Order date. Okay. This is a timestamp. Okay. So with that, actually now these three. Okay. Now I will say total is actually double. And what is my primary key? My primary key is ID and customer ID. I'm adding some rows into the orders. Okay. So let us say I'll copy this thing. Sorry, okay. I need to specify all the column name. Let's go with yes, you're right. Yeah. On your MySQL as well as any RDBMS, Oracle and everything, the same way. Yeah. So select star from orders. So now what I'll do, I will go and check So this customer, select star from orders, where customer and ID equal to see, even though it is in the primary key column, okay, so we cannot do that. Okay, so if you look at the describe orders, see, it is only the clustering key. So what we have to do? So if it is the previous thing, so what we do, we create something like a order. Okay, so that actually order customer underscore orders with the customer name and all those things, then get the data. Instead, what you could do, create custom index. Now I'm going to call this. Wow, I got it. So 2 orders, I got it. So let's go with some of the totals. Okay, so same thing with the numeric field. Let us see how it is going. Customer with the order, customer order with total ADX on total. So star from orders, total greater than 2000. I should get 1. So less than 2000 should get 1. Okay, so greater than or equal to 5000. So I'm getting this. Is it very, very easy with the storage attacks index. So at least we have eliminated, I could say, more than 3 or 4 tables. With these 2 tables, that with the storage attack index, we were able to eliminate it more. Yeah. So same thing with the customer, that you can do the index on the state, or you can do index on the zip code wise, in particular zip code, how many people are there. So you can create one of the zip code thing that you can use it. Yeah. And one more question that is being asked, actually, what is the difference between the storage attacks index and the solar index? Okay. The solar index, that we have to say where solar with that particular query, that you have to mention it. But here I have not mentioned anything on the second indexes. Whatever the column that I have had, okay, I have used the same thing. Yeah. Yeah. Okay. Describe table orders. So orders ID, customer ID, order date total. So you'll see primary key ID and customer ID. So customer ID is the clustering key. Okay. So if you look at this, actually, Astra DB compaction, it will have something like the unified compaction strategy. I think it is not available in DSC. It's available in the Astra DB. Yeah. Normally we will have SlideShare or another timestamp or whatever that compaction strategy that we use it, but here it is totally different. Unified compaction strategy, it is something like that. You have a SlideShare compaction and another compaction. These two together, that it merged into one with unified compaction strategy. Yeah. And apart from that, that you will have a all with your grace second, GC period, and everything is the same. And describe key space. So it's, if you look at the key space of the AstaDB, it is network topology by default. Okay. It is being used in Asia Southern, it is in the Mumbai. Okay. So when you create a database, you can specify where that you want to host it. Okay. In which region that you want to use it. On AWS or GCP or Azure. I think this one is right now in the GCP. Yeah. In Mumbai area. Yeah. Mumbai. In India, it is there. This is the key space, how this key space is created here. Same thing with the all the tables with everything. So with this, actually, if you look at that, actually, Cassandra, I should have a partition key, obviously. Without the partition key, no. What I do with the partition key main purpose is distributed. Okay, so all my data and everything that it will get distributed over the network, then it will go and store it instead of storing in the particular places. Okay, with the storage at an index, okay, what I can do is actually I can reduce the number of tables, okay, by creating for the query by design or for the query. Instead that those things that I can use it in the secondary indexes for that particular non-primary key or primary key, because we have shown the seen in the demo one with the primary key that with the orders with the customer ID. Okay, another one is with the total. Okay, it is totally a non-primary key. Okay, with that also we can able to create it. So with those creation that we can able to do with the querying. Okay, so how we are playing with the same secondary indexes in the RDBMS on MySQL, Oracle, or SQL Server, same thing that I can use it in the Cassandra. So anyway, so you can keep playing in the AstaDB. With this, you can attach. You can go there, and it is a free. Okay, you can go there and create a databases, tables, and you can insert and update and do all those things. Okay, get familiar, and you can still go with the how you can very normalize or very beautifully that you can define the Cassandra data model using the storage attached index. That's all from my side. So I think most of the things I covered it. What other relevant topic was there? Thank you so much. Okay, if any questions that you can put it. Yeah.
I have one more question from Buzz Lightyear. So with data already in place, creating SAI, does it take certain time for index completion?
No. Actually, it is very so fast here. So if it is going to be huge, maybe a slight delay. Okay. Other than that, actually, no. Even if you look at that here, actually, when I created it, actually, it took some time. Okay. Maybe because of the network latency and all those things. Okay. It might have taken a little bit slow time. Yeah.
All right. I want to say thanks for a fantastic talk, Val. I want to thank everybody for joining us, and Nick as well for kicking us off this afternoon. I'd like to remind everyone that we will not be having a Cassandra.Lunch next week. Instead, we'll be speaking at the Scylla DB Summit. There's more information about that on our events page. If you haven't registered, please register now. It is online and it is free. So I want to thank everybody again for joining, and we'll see you soon. Take care, everybody.
Thank you. Thank you, Akish. Thank you, Dean. Thank you, everyone.